Hi, all. Thank you so much for joining today. Today we have another great session for the Azure AD B2C webinar series, and this will be on the custom policy concepts. Today we're joined by John Garland, and he's the VP of Cloud Development from Winelect, and he'll be the main instructor today. We're also joined by Vinu, and she'll be joining a lot of the Q&A, and we'll have some time at the end as well. And if we dive into slide 2, if you haven't been able to essentially join one before, we'll be able to dive into a bit more of how the structure will work.
Okay, well, hello and welcome. My name is John Garland, and as Sophia mentioned, I'm the Vice President for Cloud Development at Winelect. We've been an award-winning Microsoft partner for many years, with a focus both on consulting and training in Azure and other Microsoft and related technologies. I'm a Microsoft Azure MVP, a Microsoft certified trainer, and an instructor at Winelect. In fact, I teach a course that Winelect offers to help our partners learn how to effectively use Azure AD B2C. You can find out more about me and Winelect at winelect.com, and I also tweet at the .NET Gator alias. Also on the call with me is Vinu from Microsoft to help handle Q&A. She's one of the Azure AD B2C product managers, wealth of information, and should be able to help along with any questions that you have as the session goes along. In this session, we'll be introducing the concepts behind Azure AD B2C custom policies. And thank you very much for joining. We're very excited that you're here today. And let's see, a recap of the previous sessions that we've already had and the sessions that are upcoming. We earlier had our sessions on identity protocols with OpenID Connect and OAuth, and Azure AD B2C and application integration with the Microsoft Authentication Library. The recordings for those will be at the links that are listed here. There's going to be a little while. They're still working on getting those recordings on up, but they're actively trying to get those up, and they should be up real soon. Our session here in green, the Custom Policies Part 1 concepts with a take-home lab. And then next week, we'll go ahead and dive into a more thorough walkthrough of the policy that's at the center of our take-home lab today. And then the final week in the series, we'll be discussing troubleshooting and other techniques involved in working with Azure AD B2C custom policies. Today's agenda, we'll be introducing some of the custom policies in Azure AD B2C, where they fit alongside the user flows that we've seen in the previous sessions. We'll look at the components that you will use to build custom policies, including relying party and the user journey declarations, the claims definitions that facilitate or that become the elements of data inside of your custom policies. We'll look at technical profiles and focus on some of the more common ones. And we'll look at what you need to do and where you can get guided instructions on how to get started developing your own Azure AD B2C custom policies. This is going to be a conceptual discussion today in this session, and we'll do a more concrete policy example in the next session in the series. A quick note, this session does assume that you're familiar with the prerequisite material that was outlined in the session invitation, and that includes knowing what is Azure AD B2C, basic Azure AD B2C configuration and user flow creation, advanced use cases with Azure AD B2C. And if you're not familiar with these topics or you want a refresher, the session invitation includes links to video tutorials that explain these concepts. Also, again, the videos are coming up. If you haven't watched the prior sessions in this series, you may want to go back and review those when you get a chance. So as we've discussed in the previous sessions, there are several common functions that applications that use Azure AD B2C to accomplish, that applications can use Azure AD B2C to accomplish. Applications integrate with Azure AD B2C by calling endpoints defined by policies or user flows, and each policy or user flow basically represents a unique identity server. Azure AD B2C simplifies this process across several platforms, web, mobile, desktop applications. They all can use modern authentication standards exposed by an Azure AD B2C tenant. And the Microsoft Identity Platform provides libraries like the Microsoft Authentication Library, or MSAL, that you can use to integrate into your application to simplify the authentication process and also the token acquisition and management. With Azure AD B2C, you can let your customers choose what identities to use to sign into your application. And that can be social accounts like Facebook, Microsoft, Google accounts, Amazon, or really any other social identity provider that supports modern identity standards. You can also connect to enterprise accounts like ADFS, Salesforce, or even end users' own company's Azure Active Directory tenant. Or you can use account-specific credentials known as local accounts. And in the end, your application is going to allow the user to interact with policies configured in your Azure AD B2C tenant configuration with the goal of having those policy endpoints return several different kinds of tokens to the calling application. So to start with, let's differentiate. Azure AD B2C supports two different kinds of policies. User flows, and those are predefined built-in policies that you can quickly configure using the Azure portal. They support really common identity needs such as sign up and sign in, with and without MFA, profile editing, self-service password reset, and other scenarios. They're customizable. They allow you to select whether or not to include external identity providers, what information to collect from users, what that information to return in tokens back to the applications. And we saw all this demonstrated in the previous sessions in the series. Azure custom policies allow you to go deeper in terms of the amount of configuration and the scenarios you may want to support. With an Azure AD B2C custom policy, you aren't limited to just sign up or sign in, password reset, and edit profile scenarios. You can really create any policy you would like. Common examples include things like linking multiple accounts together. So a user will sign in with a local account or with a particular social account, and they may want to indicate that other social identities apply to them as well. You can create policies that allow the user to change their sign-in email address or update their MFA phone numbers, for example. You can invite a user to Azure AD B2C. So instead of supporting just anyone comes in and signs up, you can actually create a scenario where a user is emailed an invitation and then uses that invitation to drive their initial registration and entry into your Azure Active Directory B2C tenant. You can make calls to external third-party services in order to validate user information, like calling credit monitoring services or other things that will help to validate if the user information that they've provided is legitimate and valid. Or you can even create a policy that runs a just-in-time migration. So this allows you to seamlessly migrate user accounts from a legacy identity solution over to Azure Active Directory B2C. When you're working with an Azure AD B2C custom policy, you're working with a policy that's made up of several distinct sections. And you specify values in each section, and you can refer to elements from other sections in order to assemble the functionality that you want your policy to achieve. And custom policies can be defined using one or more XML documents, which you then upload to your Azure AD B2C tenant. Some of these sections include things like the base policy section, which defines an inheritance hierarchy among multiple policy files. There's a building block section. In there, you configure your claims transformations, your UI content definitions, and other policy features that are kind of the core elements of the policy, the core definitions of the policy. You work with claims providers, which define items that get, change, or validate and ultimately return claims, these core values that your policies work with. And the claims providers you work with an element called a technical profile. We'll see these here in just a second. Another section is the user journey section. The user journey section defines the sequence of steps that are to be executed and the conditions under which these steps are invoked or sometimes skipped, but basically determines the technical profiles in the claims providers that refer to the building blocks that your policies are built on. And the last section is the relying party section. That defines the behavior of the endpoint that is exposed by the policy that applications call into. And that establishes which user journey gets executed, what claims are returned, and some of the other behavioral elements of those endpoints. So let's talk about the first section here. The relying party section, it refers to basically terminology in identity systems known as the relying party. The relying party application is your web application, your mobile application, your desktop application. It is the thing that relies on the policy to help it with its identity and authentication steps. The relying party section configures the claims that are returned when a token is issued as a result of calling into the policy. Several applications can actually use the same policy. It's just that any application that relies on that particular policy is going to return the same kind of token with the same kind of claims as the user has gone through the particular user journey that relying party has specified. A single application can actually also use multiple policies. So one application may have a policy that it uses for sign in and sign up. Those can be one policy or two separate policies. It can have a policy that's used for user information editing, user profile editing, a policy it's using for self-service password reset, a variety of different reasons. Basically each of those policies defines different functionality that the application needs to rely on. And like I mentioned a couple times already, the relying party section references the user journey to be executed. Now, what is the user journey? Well, the user journey is the set of steps that the user is taken through as they are presented with the particular authentication need from the application. It's, again, the journey that they end up going through. The user is taken through these steps. Each of these steps is responsible for retrieving claims or in one way or another, exchanging claims, collecting, saving, and so on. And with internal or external parties. So it'll send out input claims, receive output claims. We'll see a little bit more about this here in a section. So don't worry about it. Don't worry about it too much. Each user journey is made up of a sequence of steps. These are called orchestration steps, and they are just basically numbered steps 1, 2, 3, 4, 5. And as you go through each step, finish one step, you go on to the next, and so on and so forth. Usually, for the vast majority of cases, the final orchestration step is the one that issues the token back to the application. Let's look at this kind of visually. If you can picture this diagram here as the conceptual representation of the policy that is being accessed through the endpoint provided by the policy. The relying party application calls into the policy, and it may or may not supply some incoming claims. The user is taken through a series of steps, as you see here, step 1, 2, 3, 4, and so on and so forth, that are considered the user journey through this policy. Each step may be something like signing into a local account. Some claims come in, some claims come out. If they don't sign into a local account, maybe they'll sign into an identity provider. That could be another step. Exchanging information with a REST API, checking MFA. Basically, again, we continue to move through these steps until we reach the very, very end, at which point claims are taken and assembled into a token that is returned back to the relying party application. Let's look at this in the context of a common user journey that you'll end up seeing if you're working with custom policies. And this is what happens when a local account, when a user signs in with a local account and he's either going to sign up or sign in. So the first step the policy needs to do is it needs to show the sign-in form that contains the sign-up link, the password reset link, like you see here. If the user provides their credentials on screen, then a call is made to attempt to log in the user with those credentials to that particular account. Those credentials are validated, and if they're legitimate credentials, an object ID is returned for that user. If the user has gone ahead and done that sign-in, we're going to go ahead and skip step number 2. Otherwise, the user will be presented with a user interface to register with a new local account. Once they've provided all this information and hit the create button there at the bottom, that account will be created in the underlying directory, in the directory that underlies the Azure AD B2C tenant. Regardless of whether they've signed in or signed up, the next step, you're going to read the desired attributes out of the user directory for the current user account. You may want to get name information back out from them. You may want to get the latest, not the latest, but you may want to get ID information or other claims, other information out about the user. But you'll go ahead and retrieve that information from the underlying directory. And then the last step is you'll create a token, or actually your policy will create a token with the desired claims collected from the current user, and that will be returned onto the current app. In this case, you'll see it's returned claims related to Yoel's name and their ID within the tenant. So I've talked a bit about claims. Let's dive into what these are. So the most fundamental element that we work with in Azure AD B2C policies are claims. They're what we include in the tokens that we're returning to the calling applications. They're also used in a few different ways throughout policy execution. If you're familiar with the programming concepts, a claim is basically a variable in the program that would be our Azure AD B2C custom policy. Like a variable, it may need to be stored, and Azure AD B2C can store those variables. It's information about the user or the user's process through the policy. It can be their first name or last name or a name to be displayed. And Azure AD B2C will send claims and receive claims from internal and external parties that are part of those user journey steps. And ultimately, again, those claims or some subset of those claims is sent back to your application in the form of a token. Claims can be used in a few different ways. In some cases, they're read from, saved to, or updated in the underlying Azure Active Directory. They can be retrieved from an external identity provider, or they can be sent to and received from calls to a custom REST API service, or they can even be collected as claims from users when they interact with user interfaces that are shown by the policies. The things that the users key in, those are actually backed by claims. When you're specifying a claim inside of your Azure Active Directory B2C custom policy, you have to create what's called a claim definition. And there are a few elements that are required and a few elements that are optional in these declarations, in these definitions. At a minimum, a claim definition has to have an ID, that's the identifier that's used for the claim type, and other elements in the policy can reference this particular identifier. They have to have a display name, and that's if or if not, it's going to be shown in the user interface, it still needs a display name. Display names can be localized, but you need to specify one for each of your claims. You have to specify a data type. So again, as most variables, as many languages with variables, you have to type the variable. And you can do things like specify booleans, strings, ints, longs, dates, date times, collections of strings. There's a whole variety of different data types you can use for your claims. Outside of these required elements, there are some elements that you may want to use if you're going to be showing the claim inside of a user interface, and they will help dictate how these elements behave in the user interfaces. The first element would be the user input type, and this governs how is that claim going to be rendered on the screen. There's a whole bunch of controls that you can select from that that you can indicate will be used when this claim is displayed in the user interface. Among them, you can choose to have a claim represented as a text box. You can have a claim represented as a password, in which case the text that's entered is bulleted out as the user types it. Also, there's some special behavior also attached to passwords. You can indicate that it's going to be represented as an email address. You can have it indicated as a date, where you'll get these special controls that subdivide the date into day, month, and year. Indicate that it's numeric. You can specify that it's a drop-down list and that you're going to have the user pick one of several values that you predefine for them to select from. Or instead of selecting from a drop-down list, they can select from a radio button. They can choose multiple values from a set of items with checkboxes next to them. Or you can even have it listed as a paragraph, which is static text that the user cannot change. But this would be just a label that would be presented to the user. In addition to the input type, you can also indicate masks for data types. So when the data is returned back in the user interface, parts of the data can be hidden for security and related reasons. So, for phone numbers, you may not want to show the entire phone number, just the last few values of the number, or you may want to hide part of an email address that's being displayed. You can also choose user help text. What text is going to be displayed when the user enters an invalid value in the user interface elements. And you can indicate restrictions such as regexes. Another kind of restriction would be an enumerated list of values that will be shown in a drop-down combo box. Or you can define what are known as predicates, and predicates are complex restrictions that govern what values can be entered in there. Most of the time, what we use predicates for is password restrictions. So you see in this case, the password has been limited to what it can end with and what it can start with, the number of characters that it has to have. It can't, it has to have more than so many and less than so many. And an interesting criteria is that it has to meet 3 out of the 4 of the indicated criteria in that list. So again, typical password behavior where you want to establish a minimum complexity for the password. Azure AD B2C supports a long list of pre-built claims, and these include user attributes like given name or surname, which you may also know as first and last name, the user's city, their postal code, phone numbers, things like that. However, you may find that you may want to store some information about a user that isn't included in these predefined user claims. So to work with these kinds of additional information, Azure AD B2C supports custom claims. These are sometimes also known as extension properties, extension attributes, custom attributes. Again, the idea of customizing and or extending is usually some kind of name given to these. Custom claims extend the schema of the user objects in the Active Directory. Their definition is actually attached to an application object in the Microsoft Graph, but the value is stored with the user. With custom claims, you can store and retrieve additional information about user accounts in the underlying Azure AD data store, such as business-specific values like loyalty numbers, IDs that user records may have in external third-party systems, or user status information like the user is in the middle of being migrated from a legacy identity system. When you work with a custom claim, you will refer to it from your Azure AD B2C custom policy by the value name, prefixed with the phrase extension underscore. So extension underscore loyalty number or something along those lines. This allows the Identity Experience Framework, which is the underlying framework and runtime that supports Azure AD B2C custom policies. It allows it to locate the registered value and the corresponding claim that is stored with the user's account record. And you'll see here as an example of a returned token, you'll see it includes a loyalty number claim that's marked by the name extension underscore loyalty number and this arbitrary loyalty number that corresponds to Fred Smith's account. Now that we've talked about claims and kind of the sequence of steps that the users are taken through, let's look at the particular steps that are invoked, the technical profiles. These kind of act as the backbone of Azure AD B2C policies. All the interactions that happen in your user journey are done with technical profiles. If claims are the variables in your Active Directory B2C custom policy program, then technical profiles are the functions in those same policies. So technical profiles will allow you to communicate with internal and external parties to your Active Directory B2C. Each technical profile that you create has what's known as a protocol, and the protocol basically defines the functionality that is available in that particular technical profile. You can use protocols for a variety of open standards like OAuth and OpenID Connect and SAML, or you can do protocols for other aspects of functionality like interacting with Azure Active Directory, working with MFA with phone devices and SMS. Self-asserted, we'll talk about in a minute, that's basically user interfaces. You can work with RESTful endpoints, so making HTTP calls to remote services. Work with session management, application insights for telemetry gathering. The tokens that you're returning actually interact with a technical profile. There's a whole variety of functionality that's encapsulated by these technical profiles. Now, if we look at the diagram that we saw earlier, we'll see each of these items that sit above here. These are the technical profiles that are being called by the user journey. So there's a technical profile for the local account sign-in, a technical profile for calling the social identity provider, for calling a REST API. And each of these profiles, as you communicate with them, claims go in and then claims come back out as part of the exchange. When you're actually reading and writing these claims, claims are stored in this basically in-session memory in this thing called a claims bag. It'll be referred to when you're talking about Azure AD B2C custom policies. So again, as you call into one step, claims are taken out of the claims bag. As you come out of it, things are put back into the claims bag. Let me see if we can illustrate this and discuss this in a little more detail. So every technical profile has this same core concept. Azure AD B2C reads the claims from the claims bag, sends input claims into the operation, runs some variety of claim transformations, and then communicates with the configured protocol, such as identity provider or REST API or Active Directory services. After the process finished, the technical profile returns the output claims and may run some transformations as well. Let's look at this. Let's kind of go through each step here and break each one of them down a little bit. So first of all, when you declare a technical profile, you can indicate one or more of what's known as claims transformations. Transformations allow you to set or alter claims before the technical profile is actually executed. Then, for some technical profiles, you may need to specify a set of input claims. For example, when you're calling a REST API, input claims are used to specify the values that are sent over to the REST service as inputs to that remote service. When you're collecting information from the user in a user interface, input claims are used to pre-fill the claims on the screen. And then when you're reading or updating a user profile, input claims are used to specify the stored user unique ID to work with, like the user object's ID, their sign-in name, or their user principal name. When once you've gathered the input claims, the technical profile actually executes. So whatever its particular function, whatever its protocol is, it actually executes that operation. Those might include taking the user to a social identity provider to complete a sign-in. And after successful sign-in, the user will be returned back to the Azure AD B2C, and the technical profile execution will continue on to the next step. They can call a REST API while sending parameters as input claims and getting information back as these output claims that we'll talk about in a second. They can create or update accounts inside of the underlying Active Directory data store, or they can send and verify MFA text messages. For a technical profile that presents user interfaces, what's known as a self-asserted technical profile, you can actually call another step, which would be an input validation technical profile. The validation technical profile validates the data that's provided by the user, and it might return an error message depending on the user input. It may also optionally return one or more output claims back to the original technical profile. An example of this, when a user signs in with a local account, Azure AD B2C will call a validation technical profile to see, are these legitimate credentials? Do these credentials work for this particular user? And another example, before Azure AD B2C creates a new account, it might check whether or not a user with that particular email address already exists in the underlying directory. Once we're finished with the technical profile execution and the optional validation technical profiles, we get to our output claims. These are the claims that are to be returned back to the claims bag at the end of the operation of the technical profile. Those claims that are then put back in the bag, you can pick those back up as input claims and use them in subsequent orchestration steps or other output claims transformations, which takes us to the output claim transformation. Like the input transformations, a technical profile can contain one or more output transformations to be executed, and these result in either modifying claims within the claims bag or adding yet even more claims to the claims bag. Consider an example of this. When you're signing in with a Facebook account, the technical profile that talks to Facebook reads the Facebook unique identifier and returns a claims, and then runs a claims transformation to create the Azure AD B2C user principal name and the Azure AD B2C social account unique identifier. And that unique identifier is a combination of the user ID and the Facebook provider name. And then this is stored into that claims bag, and later orchestration steps, later technical profiles can retrieve that through their input claim transformation, through their input claims, and use that in the execution of their operations. The last step in all of this, a technical profile can contain a reference to a session management technical profile, which is a special kind of technical profile that is used to manage state related to user single sign-on. Okay, there's a lot to go over there. I'm hoping it didn't sail too high, but we're going to dive into a couple of these technical profiles here and explain how they work, and hopefully that'll provide some context about that more general information. So the first kind of technical profile that I want to discuss here is the self-asserted technical profile. All interactions when a user is going to be providing input are managed through self-asserted technical profiles. These are the user interface presenting technical profiles. With a self-asserted technical profile, you configure the input claims, and those will be used to seed any user interface elements that are going to be displayed. If you already know the user's email address, or you already know their first name and you want that to appear in the UI, you would use an input claim to make sure that that value is shown there. You specify what claims will be displayed or collected from the end user, and then what output claims will end up getting pushed back into the claims bag at the end of when their user is done with the particular user interface screen. The layouts of user interfaces in Azure AD B2C are defined by the content definition setting on the self-asserted technical profile. You can customize the user interfaces by specifying a URL in the content definition element with customized HTML content, and you can get pixel-specific definition of the layout of the user interface elements in your Azure AD B2C user interfaces. What this does is it actually merges code in the customer's browser and combines the HTML that you specify, the Azure AD B2C content, they get merged together, and that's what ends up getting rendered in the end user's browser. A couple examples of different ways that this can look for you. You've got the classic screen for Azure AD B2C with the cartoon folks, maybe collecting a sign up or sign in experience for users. We've also got some stylized templates where you can use these blue backgrounds and collecting user profile information, or a gray background to have a user sign up. You can select which one of those templates to select, or you can provide a customized template like the one shown in the middle for this Woodgrove Groceries grocery stand, where it absolutely has the look and the feel of the Woodgrove Groceries business, rather than something that looks specific to a Microsoft service. So the next thing to discuss is validation technical profiles. A self-asserted, and only a self-asserted technical profile, can define one or more validation technical profiles, and these are used mostly to validate output claims, but they can also be used to supplement the process of collecting user input information. So a validation technical profile is just another technical profile from any protocol like Azure Active Directory or REST API. And when it's invoked, the output claims coming from the self-asserted technical profile are available to that validation profile, and it can either return a set of output claims on its own of having called this other profile, or it can return an HTTP error message. Some examples of this kind of behavior: when you're signing in with a local account, Azure AD B2C will invoke a validation technical profile to check and to contact the OpenID Connect endpoint, the OAuth endpoint, and validate the user's credentials and return the user's object ID. OpenID Connect. It is OpenID Connect. On sign up, Azure AD B2C will invoke a validation technical profile and check the underlying Azure AD data store and see, well, does this account already exist? And if it doesn't, great, create the account. As part of the validation technical profile, it will actually create that account and return back the object ID for the user. You can also add additional validation technical profiles to see if the user exists in your own company's database. If you have a record and you're restricting users based on only ones that exist inside of your existing systems, you can update your internal system when a user has changed their profile. So if they've modified their last name and you're keeping last name both in your system and in Azure AD B2C, you can update them both as part of a validation technical profile. A variety of different business logic concepts that you can exercise as part of the validation technical profile. Let's see this, kind of illustrated. Think about this when I'm doing a sign in inside of a sign up or a sign in display. You'll see, as the user enters their email address and clicks on password, the first thing that'll happen is the validation technical profile will validate those credentials, and then it may execute yet another validation technical profile, which would be a custom, a call to a custom REST API. Speaking of custom REST APIs, that's another example of an Azure AD B2C technical profile. It lets you make calls to an HTTP endpoint from within your own policy's execution. This can be really, really useful. You can use it to validate user input data. So check that the user's, the information the user has entered is valid. Maybe you want to call to a third-party remote service and make sure that the user has entered a legitimate credit card number or a legitimate social security number, or their email matches up to their address information, or whatever you may want to do there. But you can provide that extra level of validation by calling into these external services. You can overwrite input claims and correct or sanitize data. If the user has entered their first name in all lowercase or all uppercase, you could actually reformat that string and return it back as a modified claim. Or you can enrich the user data by going out to corporate line of business applications. Your REST service can, given the user's email address, they can go into our customer record database and pull the user's loyalty number out and return it back to Azure AD B2C. And then that can be stored either stored in the Azure's AD B2C account, or it can just be used in subsequent orchestration steps. And it can be returned in the eventual token that is returned from calling the policy. Or you can just kind of run other custom business logic, and you may want to send push notifications to users' devices, update corporate databases, run some kind of a migration process. Anything that you can imagine, once you've gotten into that remote function, as long as you've got that logic coded there, it can become part of your policy execution. In this example, I'm collecting a user ID. So the user is going to sign in. As part of the policy, we'll call a RESTful service and try and retrieve the user's loyalty number, the user's grocery store points card number, if you will. We retrieve that from our service, and if they're required to have it, we can return an error message back and say, we don't know who you are. Please sign in with a real email address or an email address that we recognize. Or if they have provided the value, you can then store that value in a claim and return it on through the application. Now, let's put all these concepts together a bit. We started out by talking about relying parties and the relying party policy. Your application will call the relying party policy. and this will specify which user journey gets executed. The user journey is going to define the sequence of steps that the user experience, that will guide the user experience through the policy. Each user journey will be made up of a set of orchestration steps. These steps perform a series of actions in a specified sequence. They actually evaluate these things called preconditions to determine if or if not the step should be executed. And ultimately, we'll call a technical profile. The technical profile will provide a framework to communicate with different types of parties through these predefined protocols, and they may gather, modify, or store one or more claims that get put into the claims bag and taken out of the claims bag as needed, and this process continues until a token is returned at the end of the journey. Okay. Again, that was a lot to present. Getting started, so that's a lot of great conceptual background, but how do I get started working on an Azure AD B2C custom policy? The first step, you have to create an Azure AD B2C tenant and link it to an Azure subscription. We saw this, Jenny went over this in the first session in this series. You will have to define a few artifacts that custom policies are going to rely on. You'll have to define a signing and encryption keys to be used by your policies. You'll have to register a couple of applications that allow you to sign in local accounts. You'll have to retrieve some values, some IDs that are used to allow your policies to work with custom claims. And if you're working with an external identity provider like a Facebook or a Twitter, you'll have to register an application with that identity provider. That registration in turn will give you a set of values that you will use in your custom policy to configure the interaction from the custom policy to the remote identity provider. And then the next thing you'll do is you'll download a custom policy starter pack, which is we'll talk about in a second, but a set of files that get you along the way for working with policies, and you'll update some values in that. Don't panic. All of this is defined in the documentation for Azure AD B2C, and the steps are very well specified in that documentation. So I mentioned the custom policy starter pack. What's the deal with a starter pack? Why do we need a starter pack? Well, the starter pack provides a common starting point for us to work on with our policies. It defines some very common user journeys and the steps that are entailed. It has the definitions for a variety of different claim types. It's built to help support change management. So there's a hierarchy that we'll talk about here in a second that facilitates change management and configuration. And these starter packs are maintained and tested by the Azure AD B2C team itself. The starter packs are broken into a few different sections. There's starter packs for working with local accounts, for working with social accounts, for working with a combination of social and local accounts, and the most recent addition for working with a combination of social and local accounts where MFA is multi-factor authentication is enabled. Within each of those sections, there are predefined relying party declarations for sign up and sign in journeys, for edit profile journeys, and for password reset journeys. And of course, you can define your own, but you have a structure and an example of how these things already work. This is ready to use, and you can just dive in, make changes, rather than start with a blank piece of paper and try and figure out where to go from there. There is a hierarchy that is recommended and suggested with the starter pack policies. And Azure AD B2C custom policies work with this kind of hierarchy or inheritance model. At the very bottom, the relying party policies down here in this bottom row, they actually inherit values from each of their subsequent parents and allow you to either augment what's declared inside of there, or you can override what's declared in a parent. Let's see. So everything that's defined in the base file is inherited into the extensions file, and in a few cases, the extension file augments and overrides those values. And then going on down, the individual relying party files provide, generally they just provide the relying party definition on top of what's been defined inside of the extensions. And again, you can create more and more relying party policies that share the common items that are defined in the middle extension policy. You actually aren't limited to a 3-deep inheritance file like this. In our exercise, we're actually going to be working with a 4-deep inheritance. It's whatever works for you, whatever makes sense. Just like class definitions in an object-oriented language, how deep should a hierarchy be? It should be as deep as you need it to be. And in this case, it's very much the same. You should create seriously consider this 3-deep hierarchy, but you can create additional levels as your needs happen to dictate. Now this takes us for our exercise, our lab that we're going to be presenting to you this week. We'll go over the details of it in the following session in this series. So the exercise we're going over with is one that involves implementing progressive profiling inside of an Azure AD B2C policy. Pretend that your manager has come to you and asked you to create a user sign-in flow that allows new users to sign up or existing users to sign in. Users are going to be creating credentials local to the application only. We're not worried about external identity providers quite yet, but they may at some point down the road. The B2C user account should record a user's loyalty number. Again, this is that grocery store points club membership type of number. But we don't want to bother the user too much when they first sign in to our application, when they're first signing up. If you gather too much information from them, you might scare them away. And so we're just going to keep their initial sign up very, very basic. But the next time they sign in, we're going to realize that we haven't gathered all the information that we need from them, and we're going to prompt them for some additional information, specifically their loyalty ID number. The lab, if you want to walk through it between now and the subsequent session in this series, is available at that URL there, and I believe the URL will be posted here in the QA shortly if it hasn't already. And with that, certainly, if you please take a few minutes to complete the feedback for the survey. Hopefully you filled out the pre-survey now that we've got the post-survey. And we have a few minutes left to go over any questions that you may have. So thank you. And are there any questions?
I'm just going to see if we can to some extent. More guidance on when to add content to which relying party XML file would be helpful.
Okay. Yes, that makes sense. Yeah. The question being, okay, so when do I know what to put into the base file and what to put into the extensions file and what to put into the relying party file? The general convention is the base file gets left alone as much as is possible. Use that to be the core definitions that the Azure AD B2C team has provided. You can think of it almost as the object class inside of a C# or a .NET type of environment. It is the core definitions. Beyond that, the extensions file is largely your playground. That is where you will define the additional claims, where you may define extensions to things like the policies that read and write from the underlying Azure Active Directory data store, where you'll provide ID values for that your policy will need to interact with other parties, define additional technical profiles in here. And even convention is generally that the user journeys are defined at this level quite often. And then the relying party file tends to often only be just relying party elements. Myself, in my experience, I tend to mix the user journey declaration and the relying party declaration in that lowermost relying party file because they tend to be very one-to-one in my environments. But if there is any sharing, then you would move them up into that. Beyond that, do you want to create additional files? And it depends on your needs. Every organization is going to be a little bit different, but you may have custom claims that you want to establish company-wide, if you will, that span many multiple applications. And that may drive for yet another extension file in the hierarchy that is the company common extensions file. And that itself inherits from the base, and then the other extensions would inherit from this company one. Again, just like a base class file might in an object-oriented type of programming language.
Awesome. Yeah, thank you for that great explanation, John. We have another question. Why are policies named as B2C_1A? What does 1A mean? I can possibly take that because I work at Microsoft. That's just, we just use this for routing purposes. When we see B2C_1A, we just know it's a, B2C, it has to be redirected to B2C. That's the only reason. And you have to stick to it. That's just the norm that we follow internally. I hope that answers that question. And there's another question, how do we verify while entering the new password does not exist in the old password history? John, do you want to take that, or do you want me to take that?
I'll take a stab at it, and we'll see. So again, you're asking for a custom behavior relating to, you see this in a lot of organizations, they have some internal policy where you want to ensure that a user cannot reuse a password across their last X number of passwords, and that they're not repeating passwords. This is definitely something that is in the area of custom policies. What you would need to do is you would need to create a storage area where you are going to record hashed versions of those passwords. You don't want to store the passwords in the clear, but you want to store maybe hashed versions of those passwords, and use a custom policy to call perhaps a REST technical profile to access those saved values and check, is the password that was entered in one of those values? This would be a use for a validation technical profile. There is a set of sample technical profiles that are defined that address a lot of common use case scenarios, and I know that this is one of the ones that's listed there, and that'll explain or give you an example of a policy that implements this exact scenario.
Yeah, and just like John said, if you want to store the password history and if you want to compare it to previous passwords, then you have to store it externally, the hashes of the old password. But if you're only checking against the last password used, you don't need an external storage of any sort. You can just compare if the current password is equal to the new password. And we also have a sample for that I pasted in the Q&A window.
Very good point. Yeah, I was thinking just about the previous end, but yeah, if you want to make sure that they don't just match one for one, absolutely.
Okay, let's see what else we have here. I'm just reading this out loud. It's a long question. So slightly off topic, but is there a way to brand the MFA screen where the user needs to enter the code from their phone? So instead of the cube that shows up in the top of the dialog box, maybe a company logo. So this is about the customization, but specifically for the MFA screen, John.
Okay, I think I follow you. Again, you want your own look and feel for that screen. There's a couple of different ways to achieve what you're describing. If you're just using the built-in MFA functionality, any user interface that is shown by Azure Active Directory B2C can be customized. And what you can do is you can use styling, CSS, basically with the HTML that you provide, and that you can use that CSS to catch the classes for the elements that are going to be rendered by Azure AD B2C itself, and again, style those, move those. To some extent, you can even use JavaScript to reposition those or interact with those. There are some limitations in the documentation about what you can and cannot do with the JavaScript there, but you can use that to augment the customization of the screen. You can also use the policy known as the one-time passcode, the OTP policy, and take on some of the responsibility for the MFA interaction, although I would leave the SMS-based MFA in Microsoft's capable hands. But if you're doing something like email MFA, you can use the OTP policies and gather additional control over that and maybe split screens or something like that.
Yeah, absolutely. So moving on to the next, it's actually a comment. Nice set of blog posts on Wintellect. Yeah, I can definitely attest to that. Sometimes I go and read myself on the Wintellect. So thank you, John, for that. And speaking of that, if any of you are interested in participating in the community and want to present, feel free to reach out to us using the post survey, and we'd be happy to get in touch.
Absolutely. Thank you very much for the feedback about those blog posts. The series is over, but the blogging isn't. There will be more to come in the very near future.
Okay, so the next question is, any link about biometric integration?
I don't know if the samples have anything about biometric integration. I don't know anything off the top of my head. We'd have to dig into that a little bit.
Yeah, we do have, we had a sample in the past for the Apple Touch ID, integration, but I'm not sure if it's in the newer GitHub sample. So I'll have to look that up, and if not, then we have to post it. But we can take that action item. Okay, so there's another question. Is there any password expiry policy in the built-in capabilities? Something like expire password in 90 days.
It's another common ask, and the quick answer is no, there is not. I would caution you, and I know sometimes this is rowing upstream, look at the material and the guidance. Rather than dive into solving the problem here, look into the material and the guidance by NIST, by the British equivalent of NIST, and by Microsoft itself. Periodic password expiration has kind of become an anti-pattern in the industry. What they're finding is people react to password expiration policies in very predictable ways, and rather than strengthen your security posture, they're finding empirically that it actually weakens your company's security posture. Now, that being said, you might be a developer having an argument with someone in the C-suites about this and not in the best possible situation to win that argument. The examples that we talked to that refer to the ability to look for previous passwords also include examples for how to implement a password expiration policy. The trick is you record a custom claim that indicates when the user last signed in with that password, or when that particular password was created, depending on what your organizational need is there. And then as you're going through the user flow, you can check against that particular value that you've stored.
Great, and we're about 2 more minutes left, so there may be time for about one more final question to wrap up today's session.
Just one, we can take this. Is there any integration with FIDO? John, do you want to take that, or do you want me to take that?
Oh, I'm going to let you handle that one.
Yeah. Okay, so we have a sample on GitHub, but that's a bit of a workaround. But FIDO on B2C is on the roadmap, but I don't have any specific timeline to share at the moment.
Well, that was the last question. Thank you all so very much for attending today, and we hope to see you at the next session.
Great, thank you so much, John, Vinu. Thank you so much for joining, and thanks to everyone else as well. We look forward to seeing you in next week's session. Thank you.